I built my own macro pad from scratch, and it completely changed my desk setup. Now I can launch my apps with just a single button press. I designed this fast and flawless system entirely for my own needs, and I'm sharing the whole process so you can build one for your desk too. Plus, with this guide, you'll be able to assign the keys exactly to your own workflow. What parts I used, how I did the wiring, I explain it all step by step. If you want to see more projects like this, don't forget to subscribe to the channel and hit the like button. If you're ready, let's get started. Our first component is the 2.8-inch ILI9341 TFT display. Using the pins on the back, we will connect it to the ESP32 via SPI. We will monitor all our custom shortcuts directly on this screen. Our second component is the ESP32-S3 development board. Thanks to its native USB support, it connects directly to our computer as a keyboard and will manage all our buttons. Our third component is a rotary encoder. We will use it to adjust the volume and press it to play or pause media. Our fourth component is the 12mm tactile push button. These will serve as our main keys for all shortcuts. Our fifth component is the male and female header pins. We will use them for the screen and the ESP32 board to mount them easily and make them detachable. Our sixth component is the 10,000 ohm resistors. We will use them for stable button operations. And our final component, the Perfboard. Except for the display, we will place and align all the electronic parts we just mentioned onto this single board. If you're completely ready, let's start the soldering process. finally, all the soldering stages are finished, our hardware is ready. Now we move on to the most exciting part. Let's head over to the computer together and upload the codes using Arduino IDE. The first thing we need to do is copy the codes into a new sketch and then scroll to the very top. This is where we will modify our Wi-Fi credentials, API key, and city settings right inside these top definitions. To fetch the weather data, we head over to the OpenWeatherMap website. Simply create a free account and generate your own API key right under the Create Key section. First, we go to Preferences under the File menu. Next, we paste our link into the field in the pop-up window and click OK. As you can see, after confirming, Arduino IDE automatically starts downloading the ESP32 JSON file in the background. To run the code, first, I install the ESP32 board support via the board's manager. Next, we go to the library manager to download the LovyanGFX library for our display driver. As you can see, I've already installed both beforehand, so we can jump straight into the next step without making the video any longer. Before uploading the code, we verify our settings under the Tools menu. We set the board to ESP32-S3 dev module and select the correct COM port. After changing USB-C/DC on boot to enabled, we set the flash size to 16 megabytes and finally configure the PSRAM as OPI PSRAM. Once these critical settings are done, we are ready to hit upload. And then we click the arrow icon at the top, which is the upload button, and wait for the codes to flash. Since this part takes a bit long, I sped up the video right here. As you can see, everything is going perfectly well, and we are moving forward without any issues. I uploaded the complete code to GitHub, and you can find the link in the video description below. I also included the circuit schematic and the pin wiring guide in the exact same GitHub repository, just in case you get stuck. With the libraries compiled and the upload bar hitting 100%, we have now successfully wrapped up the software side of things. Of course, before heading into the final results, don't forget to subscribe to my channel, like the video, and drop a comment down below. Now, let's jump in and see this awesome macro pad in action. Here, we connect the USB cable to our ESP32 board and eagerly wait for the system to boot up for the first time. As you can see, our display turned on perfectly, connected to the Wi-Fi network, and successfully fetched the live weather data for Izmir. Here, I pressed the button, and as you can see, it works absolutely flawlessly. In the near future, I will be designing a sleek 3D printed case for this device and adding even more features to the code. Make sure to stay tuned and follow along so you don't miss any of the updates.